Do you want to present your research and connect with other geoscientists? Well, the perfect opportunity, GSA Connects, or the Geological Society of America's annual meeting, is happening here in San Antonio, Texas, this October 2025. And whether you're a student, a working professional, or just someone interested in earth science, environmental science, planetary science, and related fields, this is such a fun meeting. Whether you just want to attend and see other cool research going on, or present your own research, or come to one of the field trips where you get to explore the regional geology. But in this video specifically, I will be going through the program for this year, so all the topics to be covered at the meeting this year, as well as how you can write and submit your own abstract if you'd like to present. So let's get into the topics that will be covered at this meeting, how you can explore the program yourself, and how you can find a topical session that fits your research and that you can submit your abstract to. So the first thing you're going to want to do is go to the GSA Connects 2025 website. If you just Google GSA Connects 2025, you'll find it. And then when you click on that, you'll see this page. You can either explore GSA Connects. It'll bring you to a ton of cool places where you can learn about where it's going to be and some information about that location. Spoiler alert, I will be having a lot of videos coming out here soon about the San Antonio region, its geology, and some fun field trips that GSA will be offering that you can go on in and around the area. But for this video, like I mentioned, we're going to go through the topical sessions. So click on Submit an Abstract, and it'll take you to this page where you can see the deadline. So technically, this is actually the first year they're doing this, but the deadline, the final deadline for abstract submission is until August 5th. So you got some time. But there is a May 15th deadline, an early deadline for those of you who maybe you're an international student and you want to come to the meeting, but you want to plan your travel super early. Well, for that, you might need an earlier notice of abstract acceptance. So you can submit your abstract by May 15th to get an earlier answer of whether it's been accepted or not to the program. So I highly recommend that for those of you that need to know sooner. However, for those of you that maybe are local or can plan your trip later, the August 5th deadline is the final abstract deadline. And so where do you actually submit your abstract? Well, if you scroll down, you see topical sessions and discipline sessions. Topical sessions are sessions that have been proposed by various scientists, GSA members around the world to host a session about a particular topic, a very specific topic within different disciplines. And so we'll focus on these for this video. However, if you cannot find a topical session that you think your abstract fits into, you can submit an abstract under the discipline sessions. So essentially you just press discipline sessions and it takes you directly to this abstract submission page. And we'll go through this later, but the only difference between submitting an abstract to a discipline section and a topical session is for the discipline sessions, you essentially just select what discipline your abstract falls under or your research. You can select multiple, you can select a primary, a secondary, etc. Just so that gives the meeting organizer some idea of how to categorize your presentation and put it in one of these sessions. But we will be going through the topical sessions. So come back to this page now, this tab about the deadlines and stuff. If you go to the bottom, you'll see topical sessions and click on that. And it'll bring you to this page where you can start reading through the topical sessions. This is just an alphabetical order, but there's so many, guys. So my recommendation to go through this is to go over here to the right side of the page, and you can search for key terms like climate, for example. And that brings up any sessions that are at all related to climate or have the term climate in them. But another thing you can do, and I'm going to take this away and let's go to primary discipline, is you can filter by the discipline that you research. So for example, my research back when I was doing my PhD was Paleoceanography. So here's Paleoclimatology and Paleoceanography. So if I click that, it takes me to a new page that's just showing those sessions that are related to that topic. So climate transitions in the Paleozoic, climate, ocean, and environmental changes through Earth's history. That sounds really interesting, actually. Marine and terrestrial proxies. Wow, that's cool. I didn't even know there were that many terrestrial proxies. Modeling to reconstruct rapid ocean. That sounds actually really cool. Microfossils of extremophiles. Whoa, that's awesome. Extremophiles are organisms that live in really extreme environments. And I've only really heard of research into these extremophiles in the modern, but microfossils implies that people are researching ancient extremophiles, which is super cool, and has implications for astrobiology, looking for life on other worlds like Mars and Mars rocks. And then we've got environmental instability during greenhouse periods, more microfossil insights, sedimentary record of climate change, long and short-term environmental consequences of large igneous provinces. Those have caused a lot of mass extinctions in Earth's past, which is super fun and cool to learn about after the fact, obviously. Then we've got oceanic event during the Cretaceous Interior Seaway. Okay, so this is really cool because it's locally relevant. We're having a conference in San Antonio, right? And spoiler alert for future videos that I'm gonna do from the actual area, there is pretty much all the rocks there. There's limestone and chalk and stuff that was all deposited during the Cretaceous in this seaway. And so there's a lot of sessions I'm sure that will be kind of locally relevant like this, which is super cool. Then if we go back up, let's change it now to, energy geology. Maybe we'll do energy geology and economic geology and engineering geology. I'm just doing all of it. Okay, well, we'll do those three, see what comes up. All right, here we go. Let's see. Critical mineral resources and recovery in the Americas, emerging methods in exploration and sustainable extraction. Super important and relevant to today. Wow, that's actually, I might do an interview with them to post it on the channel. Emerging voices in energy geology research, contributions from students and early career professionals. So a lot of times GSA does these emerging voices or new voices in blank sessions, and that's to get students and early career professionals to present research and kind of get talking with the senior researchers in that field, and that creates a lot of great collaboration. So these are really great sessions as well. And they also, foster collaboration between those students and early career professionals, which they'll continue to build up upon throughout their career, which is really cool. And it builds a lot of relationships. And oh my God, I know Doctor Who. That's actually really cool. Then we have more energy geology, estimating natural resources using geoscience data, faults, fractures, and geomechanics for the energy transition. Hey, there's Doctor Who again. He was one of my professors at UT Arlington when I was an undergrad. Sedimentary geology and energy transitions. Hey, there's Andrew Lear. He's one of my colleagues at USC. Lacustrine depositional systems around the world, a growing energy resource. Interesting. Oh my God, there's Doctor Who again. I actually didn't know lacustrine systems were a growing energy resource. Or lacustrine is lake systems. Interesting. Okay, cool. I might look into that. Landslide instrumentation and monitoring systems. That's important. Natural hazard risk assessment and monitoring. That's really another landslide one. Mapping, next steps. Micro nanoscale pore fracture architecture and fluid dynamics in shale and coal reservoirs. That sounds intense. Okay, critical minerals, recovery of critical minerals. That's super important right now. Sustainable critical mineral extraction for the global energy transition. That's super relevant right now as well. Okay, so there's tons of really cool energy geology and economic geology and engineering geology stuff. Let's now uncheck those and let's check out tectonics. Tectonics is fun. Okay, we've got advancing earthquake geology and superficial deformation through multidisciplinary high-res data. Earthquake hazards and boundaries. And so lots of natural hazard stuff. This is super, super important and really, really cool. Exploring feedbacks between tectonics and climate on lithospheric evolution using multidisciplinary approaches. That's really cool. Tectonics and climate. I love that. Presentations of geoscience in Spanish. You guys, oh my God, talk about accessibility. Jay Chapman, he's one of my old professors from UTEP. That is really cool. Oh my gosh. Questioning conventional wisdom. I love that. That's what we always have to be doing in science to move science forward. More sessions in Spanish. You guys. All right, let's uncheck tectonics and look at karst. Oh, that's going to be fun. Cave and karst biogeochemistry. That already sounds amazing. Hey, I know Laura. Oh my God, that's so cool. Another thing that GSA is just the best at is like just connecting with the people that you haven't seen in forever, or people that maybe you've cited but you haven't met in person. It seems so scary to meet the authors that you have read their papers and cited them in your work. And you know, they're just people and they're at these conferences, and it's so great to build your network, to go to these places and meet these people. It's just so good. Okay, anyway, we've got communicating karst. Oh, I love that as a science communicator. That's really awesome. Hypogene speleogenesis. I assume this means something about cave formation, like how speleothems form, given that it's speleogenesis, but I don't know what these words mean. I'm curious about that now. Karst hazards and monitoring. Again, good natural hazard stuff here. Karst hydrology and hydrogeology. Karst sedimentary, paleoclimate, and historical records. So cool. There's also going to be there it is, Alexander Janelle. That is one of the field trip leaders on the field trip to the Natural Bridge Caverns and the Cave Without a Name. Yes, it's really called that. And it's going to be super cool. I got to visit. I have a video coming out soon that, I go through that cave with a wonderful student from UTSA, and I'll talk more about it there. But really cool cave stuff going to be at this meeting, and locally relevant as well. Okay, let's go back up, uncheck that. And now let's look at environmental. Okay, we've got a change in focus for sustainability in geoscience education. We've got advances in geospatial applications for environmental and engineering geology. We've got dynamics of natural and built environments. Ooh, natural and built environments. That's interesting. We've got federal PFAS remediation, successes and challenges. That's important. Fixing the silent leak. Identifying, quantifying, prioritizing, and mitigating the environmental and health impacts of legacy oil and gas drilling in North America. Very interesting. We've got microplastics in the environment. I think I'm going to try and reach out to these people for an interview because that sounds really important. Okay, lastly, let's pick. We got to do it. We got to do Planetary, because one of the themes, actually, you can search by theme as well, but one of the themes for this year's meeting is From Earth to the Cosmos, Geoscience Beyond Our Planet. Let's check that as well. Okay, let's see. Advancing mineral science and exploring planetary surfaces, asteroid observation, return missions, and meteorites, even better than the real thing, development, production, and properties of analogs and simulants for solar system materials. Exploring the diversity of volcanism in the solar system. Ooh, I predict some IO presentations there. Extraterrestrial soils, processes, properties, and implications. That sounds amazing. The rise of icy ocean worlds. Yes. Erin Leonard, I interviewed her last year for the Europa Clipper mission. You should go check that out. From atoms to asteroids and habitable planets. Impact crater processes. Lunar science and exploration in the Artemis era, mantle plumes on terrestrial planets, including Earth, planetary exploration and education, geologic mapping of different planets, powering discovery using 3D petrology. I'm looking for a very specific one. Recent volcanism on the moon. Ooh, wow, didn't know that. Silica-rich meteorites and petrogenesis of early planetesimal crust. Ooh, this is the one I wanted to find. Tiny worlds with big potential. I'm definitely reaching out to them for an interview. This session, I'm just so excited for this. And I know Jennifer, she's great. Oh my God. Okay, so now you've seen how you can kind of explore the topical sessions. And now if you choose one you want to submit to, let's just go ahead and choose Tiny Worlds with Big Potential. Submit abstract, you press that button, and it takes you to this page where you submit the abstract. So it has several steps, which you can see on the tabs at the top, and you can kind of shift around a little bit. But just to walk through this really quick, The first step is preparing for an abstract submission. So there is some information here that GSA gives you to help you throughout the process of submitting your abstract. You will be asked your preferred mode of presentation, whether you want to present an oral talk, which are typically like 10 minutes with 2 minutes for questions, so 12 total. A poster, you just want to put your poster up and, stand there for 3 or so hours and have people come by to you and you give them your little spiel and talk to people. I find that posters are really great for not yet completed research or maybe just a proposal of future research. And you get to kind of get the opinions of a bunch of different people and talk to a lot of people, maybe that have more expertise than you or less. And you get tons of different perspectives that way. Posters are great for preliminary or planned research, whereas oral presentations are a little bit better for like done research. You've published the paper, you want to share your findings with everybody. Those are good for that. Sometimes, many times, people run out of time for questions because they go over. And so you don't get as much interaction with people as you do at the posters. So if you're looking for feedback or future direction, poster is a great option. But if you don't have a preference, which this has happened to me several times in my career where I have research that I'd be happy to submit as a poster or an oral presentation, depending on what the meeting needs. And so I click either, and then they assign you based on what session you submitted to and where they kind of need you. They assign you either a poster or an oral presentation. And so after you've read through this first page, you can say save and next. And that'll bring you to the next tab, primary selection and title. So you've selected already your topical session if you went through the topical sessions to press submit abstract. And the session type is obviously topical session. So then you come back here, you can say, I agree to uphold abstract submission expected behavior policy. And then you start inputting your abstract. You put the title right here, you select your disciplines, and then you can say preferred presentation. So this is where you select poster, oral, or either. I don't know, for funsies, let's put poster. I'm not actually submitting an abstract. I'm just walking you through it. And then if you are before the deadline of May 15th and you want to receive early notice of acceptance, you select yes. If you happen to be before the May 15th deadline, but you don't care when you're noticed about your acceptance, like you aren't as rushed as maybe international students, then you can click no. That's fine. And then you say save and next. I'm not going to do that because it's going to get mad at me for not filling in everything. So I'm just going to go to funding up at the top here. And then it's asking, was the research being submitted funded by GSA or any of GSA's like sister programs? You can say yes or no. And then it's asking if you're a member of any of the divisions, the GSA member divisions, which you can be a member of multiple divisions once you're a GSA member for free. So that I'll show you in a second. But yeah, so you can click which ones you're a member of. Then we'll go to author. And this is where you add all of the authors, including yourself. So you add presenter or co-author. You're going to put in your information. If you're the presenter, you're going to select presenter. If you're a student, you're going to say yes to this question. If you're not a student, you can say no, and so on and so on. And then once you say, add, then you can also add the rest of your co-authors with their information. It pretty much just asks for your name and where you work, what university or agency or whatever you're at. Then you go to the submission fee. And you can see, so it's already pre-filled out for me what type of member I am, my name, and the fee for me. And although this says 80 because I am an early career professional, I'm not a student anymore. If you are a student member of GSA, the abstract fee is only $25. And I'm pretty sure to be a member, the fee, actually, let's go see. So if you're not a member of GSA yet, you can actually go over to their Geological Society of America or geosociety.org website and press join or renew if you were once a member. But if you scroll down on this page, you can see the fees for each type of member. Because I'm an early career professional, mine is $55 now, but let me just tell you that's a lot more affordable than a lot of other organizations in science. But if you are a student, This is, I'm telling you, the most affordable membership you can get is GSA, and it is only $25 per year. And that means that it's actually the same amount of money for you to just become a member and submit an abstract than submit an abstract as a student non-member, which is the same. It's 50, so 25 and 25, 50. So it's better for you just to become a member. You don't have to continue if you don't like it after a year, but oh my gosh, guys, GSA gives you so much helpful resources, so many opportunities. I highly recommend you become a member. It gives you so many discounts for things in the future. And if you aren't sure yet, but if you come to the meeting, whether you're presenting or just attending, if you sign up for a membership at the meeting, they always give you really cool goodies like little tote bags that say Geological Society of America, or hats and things, which is super awesome. And they also have free goodies just for anybody, even if you're not becoming a member. So I highly recommend you go by GSA's booth when you come to the meeting. But anyway, so if you want to become a member, it is slightly discounted for K through 12 teachers, very discounted for students, pretty affordable for early career professionals, and for later professionals, it's a little bit more, but still pretty reasonable for everything you get out of it. And by the way, when registration comes, which registration doesn't open for the meeting until June 3rd, but once it does, guys, it's like $100 off if you're a member. So anyway, back to our abstract submission. We've got a submission fee. Once you kind of sign to acknowledge the terms, you can go to abstract text. And then finally, you can put in the text of your abstract. And this is where you can submit, and then it takes you to a page where you pay the fee. Then you will get an email confirming that you have submitted an abstract, and a little bit later, you will get an email eventually saying whether it was accepted or rejected. Just to ease your nerves, if you are a student out there, I've never heard of anybody having an abstract rejected. If you are actually doing research or even just proposing future research, and you do put some effort into it and write a decent abstract, you'll be fine. It'll get accepted. They want to highlight as many, especially students, as they can. So don't be scared if it's your first time. And finally, let's get into how to write your abstract, which I'm not going to spend too much time on because it's really pretty simple. But I'm going to take you to the screen again. So here we're at GSA Connects 2024 meeting website. And I wanted to come here because we can check out the program from last year's meeting. Now it takes us to a new page. And what we can do once we're here is technical sessions. If you go there, you can open a bunch of technical sessions. Actually, this session has my good friend E. Wang in it. So let's open that because she was one of my very important mentors when I was at the Woods Hole Oceanographic Institution. And she does great research in non-traditional stable isotope proxies for paleoceanography. So let's go see what individual projects were submitted to this session. Okay, there's E's presentation, thallium adsorption onto natural manganese oxides, a comparison with synthesized analogs. Okay, let's click on that and see. Okay, so if here we've got the abstract. So what's in an abstract? What is an abstract? A lot of people, when you're taking intro classes in science in college or whatever, will say, it's not just a summary. It is kind of just a summary. So it's kind of just a fancy summary that we like to call abstract because we want to be fancy about it. I don't know. But what it is essentially is starting with some sentence explaining the significance or importance of this question that we still don't know the answer to. So manganese oxides are important hosts of trace metals via adsorption and or redox processes. Previous adsorption studies on synthesized manganese oxides have provided valuable insight on metal adsorption mechanisms, and yet a comparison of synthesized and natural minerals is still rare. So here she has laid out the importance of manganese oxides. They're super important in, hosting trace metals and are affected by redox processes. This is important because trace metals and their, alteration by redox processes is how we can look through the rock record for these enrichments of different trace metals, typically associated with manganese oxides, and use that to reconstruct past conditions, specifically past, for example, ocean chemistry, mainly things like redox chemistry, so whether oxygen was abundant or not, things like that. So she's laid out the importance in the first sentence. In the second sentence, she then went on to say what we still don't have or don't know. What we don't have is a comparison of synthesized to natural systems with this research. So that's what she set out to do. Here we focus on thallium as a paleoredox tracer with a major sink via manganese oxide burial to investigate whether thallium absorption and isotopic fractionation show similar behaviors on natural and synthesized manganese oxides. So essentially trying to take one trace metal that we use to reconstruct past conditions and see whether it behaves the same on synthesized materials as it does on natural materials, because this will heavily impact how we reconstruct our past conditions, because a lot of times we use what we find with synthesized materials in the lab and apply it to natural conditions, even though sometimes there's a disconnect there and processes occur differently in natural systems because there's so many more variables. So this is a super important study, and she's already laid that out. So we've talked about the significance, we've talked about what we don't have and what this study sets out to do, and then she goes into the methods that were done. So absorption experiments were performed on various natural manganese oxides with different structures and oxidation states, etc. Then we go into results. This is a classic abstract structure. Nicely done, E. So here she discusses some of her major results. Sometimes it's hard to put your results in just one or two sentences. So you really have to focus on what are the main, one or two takeaways you want readers to get out of your paper. What are the main one or two findings that your data shows? So that's what she does here. That's pretty much this entire section is her significant results. And then we finish off with a sentence kind of restating the importance of not just this kind of research, but these results specifically. So as manganese oxides play an important role in metal biogeochemical cycles, our results highlight the necessity of additional research on desorption kinetics to better understand trace element cycling in nature. So there you have a great kind of structure example. We've got importance, we've got the question or what's still unknown, what you plan to do, what your study set out to do, your methods, your results, and then the significance of those results. Okay, let's do one or two more examples just to show you some different types of studies. The Cretaceous-Paleogene boundary interval from large-scale geologic events to mass extinction mechanisms. Well, that sounds interesting. Let's see what kind of things were presented in that session. How did marine invertebrates in the Gulf Coast Plain rebound after the end Cretaceous mass extinction event? Let's check out this abstract. Ooh, we've got multiple paragraphs. Interesting. All right, so we've got the Gulf Coast Plain marine fossil assemblage at the Ouachita River near Malvern, Arkansas, contains mollusks from before and after the end Cretaceous mass extinction 66 million years ago. All right, setting the stage, some background information. Previous studies have documented a diverse vertebrate fauna at this locality, including fish, sharks, blah, blah, blah. For investigation of shallow marine invertebrate fauna, 1 gallon bulk samples were collected. Okay, so this kind of states some background information and what previous studies have found. They don't actually explicitly state that there has been a lack of invertebrate studies here, but they've talked about how there have been vertebrate fauna studied from this area. And then they go into how their methods, how they study the invertebrate fauna. So I guess that's another way you could do it. I would opt for doing something with a little bit more explanation as to what is missing after you state the significance and or background and significance. So after this paragraph, I would have added something like, there's a distinct lack of blank studies in this region. That's why we decided to do this invertebrate study. And then here's our methods, here's our results, etc. So this seems to be their methods section. Then they start talking about their results. So we've got relatively high taxonomic diversity was evident. The loss of the smallest size classes of bivalves across the boundary represents. And so they talk about their major results and their interpretations. And then they talk about how their results suggest that ecological function was restored in shallow marine ecosystems before taxonomic diversity, consistent with results from the open ocean records of the KPG. So again, kind of some background, methods, results, and significance of those results, meaning of those results. They do lack the what's missing section or sentence that some abstracts include, but to each their own. All right, let's find one more. Let's go to Tuesday. What was presented on Tuesday? Karst sedimentary paleoclimate and historical records. Yes, please. Let's learn about caves. Oh, hey, this one's in South Central Texas, which is where we'll be this year. Let's do this one. It is titled Seasonal Variations in Geochemical Characteristics of Surface Soils Controlling the Edwards Aquifer Groundwater Chemistry in South Central Texas. This is where we're going to be. We're going to be in the Edwards Aquifer. Well, we're going to be on it when we're in San Antonio at the meeting, but we're going to be in it when we go into the cavern system. Video coming soon. But anyway, this abstract by Alexander Tremblay at the University of Texas at San Antonio. I think I met this person. Anyway, the Edwards Aquifer in South Central Texas is a crucial freshwater resource for over 2.5 inhabitants in San Antonio City and surrounding areas. However, exponential human development in the recharge and contributing zones of the aquifer has created an overwhelming threat to water quality. Okay, we've got our background, what it is. We've got some, threat, significance, why this is important. And then we've got Karst features create a potential fast track for traditional and emergent contaminants to enter the confined zone. Contamination, a problem. So we've got background, significance, problem. This study aims to understand the controls that distribute chemical constituents in the Karst aquifer system through the characterization of surface soils up to 0.6 meters depth, and understanding the link to groundwater chemistry across 3 regions contributing recharge and confined zones of the Edwards Aquifer. The limestone aquifer is overlaid by clay. So now we've got what this study aims to do to solve said problem, or at least understand it better. And then we've got some more background here. This limestone is confined by blank. Then we've got the sampling. So we've got methods all across here, talking about what spectroscopic and geochemical analyses were done. Okay, then we start with the word both here. We start results. So both measurements of surface water adjacent to soil sample locations and soil leachates consistently showed alkaline characteristics. So high pH with blah, 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 blah. So we've got major results, magnesium ion concentrations, and results till the end. Okay, so this abstract, unlike the others we looked at, doesn't have kind of a, big ending sentence, a big conclusion or kind of significance of these results sentence. They just end with the results, which also is totally fine. So I think I've showed you enough examples now that you can kind of figure out how to structure your abstract. It really is dependent on, well, one, your type of study. For example, if you're just proposing future research, you obviously won't have a method section. You might have a proposed method section. You obviously won't have a results section because you're just proposing future research. You haven't done it yet. So, and I've done this. I've presented an abstract that was more of a proposal of research rather than research itself. So you can absolutely do that, and your abstract will be structured quite differently. But you can structure that kind of, what's the background? What's the problem? Where's the gap we need to fill? How are you planning on filling it? What are your proposed methods? And what would be the significance of your specific findings? Done. So, you can structure it however you want, depending on your type of study, your data, your big results, and what you want to say. There are some rules as to what kind of abstract to submit. So let's go back to this page about preparing an abstract. Let's see where those are. Okay, so here we go. Title rules, keep it to 250 characters or fewer, including spaces. As for the body of your abstract, please keep it to 375 words or fewer. That's actually more, I think, than past years that they've allowed. So I think in the past, it's been like a 300 word limit. Honestly, 375 is a lot. I used to be like, why isn't it more? But I realized through reading a lot of papers, keep it less, guys. You can say what you need to say and get the significance of your study across with 300 or less words. You don't need 375. If you've done a huge multidisciplinary collaboration study, maybe you need more, but you shouldn't need more than 375. You shouldn't need more like 250 to 300, I think. So yeah, there's information here if you go to the preparing for an abstract submission section of this little GSA abstract submission portal. But with that, again, guys, I really highly encourage you to submit an abstract. Whether you're a student or not, or whether you have started your research project or not, or just have an idea for one, it's great to go and do a poster or a talk. And although it is an amazing place to make connections and network, it's also just a great thing to put on your CV. So keep that in mind. But anyway, I really hope to see you guys at the conference. Comment below if you're going to be coming, and if you are going to be presenting, which you can attend without presenting for sure. And I'll be having videos come out soon about where you can register. But if you are going to be presenting research and submitting an abstract, please let me know in the comments below maybe what the title of your project will be. I'd love to check it out. Anyway, I'll see you guys there. Let me know in the comments too if you have any questions regarding abstract submission. I'm happy to help out, or any questions about GSA Connects in general. Anyway, I'll see you guys in the next one. Bye.